If I have graph here between V and S, that is speed or velocity versus time, so we are looking for the acceleration. Here is saying that the two balls fall from the same building here, or same height, no problem, using this graph to find the acceleration. I think we noticed that the first one moving without any effect of the air resistance. And the second is affected by the air resistance, and make here between third and fourth, that is terminal velocity. We check the second part here, it should describe the graph for volt 2. For volt 2, it is terminal velocity, decreasing before the speed gradually, and then arriving to the terminal velocity. That description. This terminal velocity, if we ask you to find it between the third and the fourth second, so what you will do, that is the third, and that is the fourth one here. So still, okay, in this, use your ruler, don't, okay, make anything without ruler. So this one becomes 8. So this terminal velocity is 8 meters per second. Don't forget the measuring units. If you write 8 only, it is incorrect. Okay? Another point to get full mark for this part, you should write it as the terminal velocity here is 8.00 meter per second. Okay, be significant. The first part here you say using this graph to find the acceleration. To find any acceleration, what we'll do, we have some, we can make in this case, that's the point, we say until the second. So use the ruler also and make vertical lines. Okay? The difference here, that is the difference between them. If you check here, that is 14. Okay, so the difference here in delta y is 14. What about delta s from 0 to 2? So in this case, we have delta v equals 14 minus 0. It is 14.0, okay, meter per second. And delta t here equals 2 minus 0. It is 2.00 seconds. Now we have delta v and delta t for the slope here, or gradient. So acceleration, as he asked it, equals delta v over delta t, change in velocity with change of time. So it will be in this case, okay, 14.0 over 2.00 meter per second, and here second, cancel second with second here, or will be up. Which one? You will cancel second with second, or will be up. Focus on this. Some students, when we made this issue, we made this mistake. Here, meter per second look like s power negative 1. And here s is down. If you make it up, it becomes s negative 1 also. So it will be s negative 1, s negative 1, and s negative 2. You know that s negative power negative 1 times s in power negative 1 could be s to power negative 2. You can write it like this, or meter per square second. Someone said that, Mr. Can we memorize it directly? Yes, we can memorize as acceleration meter per square second to be easier. Okay? If we talk about speed, it is meter per second. If we talk about distance, so we can talk about meter and so on. Okay? So if you find graphs like this, how can you find it? Okay, the acceleration. One question here is coming from Mr. Yeah. They say if we have curve, not straight line, how can we find it? Step by step. I have here, that is time, s, and this one v, meter per second, and it's look like this way. Right, what we got? Okay? So in this case, what you will do, you will make tangent here by using the ruler. Tangent like this. Okay? That is tangent. Okay? Now, in this case, how can we find it? Step by step, we have here delta y, which is equivalent to delta v, and also this part, the difference here, check this one, it will be delta x, or it is the delta time. You know that any slope as delta y over delta x. So it is delta v over delta t. You can find it. But here that is inverted. Inverted, so make it by opposites. Make it by opposites, by negative. If we draw it like this way, like this, what you will do? You will do the same. Also take a tangent here and make this one. Right? This part, that is delta x or delta t, and this part here delta y or delta v. If I have delta v and delta t, so we can find by using this law the answer. Was it?